Hello, dear teachers and jury members. Welcome to our mechatronic system design representation. I am Ekim Can Ayashlı. Other team members are Berkcan Ayteş and Kadir Yeliz. Our project is design of GPS-guided autonomous vehicle. Specifically, we are planning to use this vehicle in land vehicle tests. I will start with definition of the problem. Number of land vehicles, especially automobiles, is increasing day by day. Over 2 million land vehicles manufactured in 2019 in Turkey. These vehicles require some security tests, which must be reliable, safe, and economical. Tests should be done repeatedly under same conditions. So we need more reliable, more accurate, and better tests. Our aim in this project is building a GPS-guided autonomous vehicle for tests. GPS-guided system allow us to do accurate tests because we could do tests under same condition and with the same road. Autonomous system provides unmanned tests with moving objects. And also our vehicle has low profile with desired dummy attached to it. So in any crash, automobile only hit the soft dummy target, which causes no damage to tested vehicle. Road is user-defined in our system. So any test configuration and scenario could be implemented with our equipment. And there are academic studies about GPS-guided autonomous vehicles. Their designs are different from us and not suitable for the tests, but the GPS and autonomous system are similar. There is agriculture robot studied in Indiana University. They use RTK GPS module for high precision positioning with perception. Another example is autonomous robots studied in California State. They do not use RTK module, so their precision is low. There are commercial products for testing. In the first figure, there is stationary equipment, and in the second figure, there is moving equipment with crane. These products belong to Messring. In the third figure, Siemens product has rail system that moves to dummies. In the fourth and the fifth figure, we see DST UFO and AB Dynamics Launchpad. They are similar products with both GPS-guided autonomous driving. Dummies are attached to the top of the vehicle. These designs are going to lead us during the project.
Hi, I am Berkcan. If you look at the stakeholder expectation in the project, the most important expectation is to drive the vehicle with the help of the RC and GPS mode. In addition, errors in the following of the rules should be minimized. The interface of the system should be easy to use. If you look at some other expectations, the speed of the vehicle should be determined by user, like 15 km/h. It should be low profile, and it also handle certain weights, for instance 15 kg. We can separate technical requirements into mechanical, electronic, and software. For mechanical design, the vehicle will be designed as a low profile with 4 wheels. Differential driving method will be used in the vehicle. If you look at electronical requirements, hub motor and motor drivers will be used for vehicle movement. In GPS mode, we will use real-time, kinematic, GNSS, and GSM module shield. Arduino, Raspberry Pi, RF modules, and remote control will be used in control units. Finally, if you look at software part, Python and Arduino will be used for the motor drivers. Programs such as ROS and AutoWare will be used to create and follow routes. We are considering LG simulation program for simulate trails. Finally, C# will be used for the user interface. By the way, the determined requirements may change in the future. If you look at the flowchart, we will see the movement of the system depending on the used mode. In RC mode, we will see system constantly monitor the inputs from the user and applies them accordingly. In GPS mode, it desires to provide the drive vehicle with routes created by user. Switching between modes is possible. Flowchart of the system may evolve and change as the project progresses.
Hi, I am Kadir. We decided to use the SolidWorks program while doing a mechanical design and analysis. The materials we will use in the vehicle are as follows. We will use aluminum signal profile for the chassis. We will use a hub motor as a motor. Our vehicle will be driven by 2 wheels and the steering will be differential driving. One of the main goals of our project is to make the vehicle as fast as we can. Mechanical dimension can be variable in this process. Therefore, exact measurements will be decided later.
In the electrical design part, the connection of motor, motor-driven, and battery is the important and should be studied. These are the main part movement of the vehicle. RC receivers, GNSS, and GSM modules connection with Raspberry Pi should be studied. This connection will be used in RC and GPS mode. In addition, we should pay attention to the connection at this equipment with the battery. If we look at the GPS mode in more detail, first, the routes will be created with Google Earth or RC driving. The creating route will be arranged with roads for suitable to next process. Then, the path smoothing process will be done with help of AutoWare. In here, with the purposed route will become suitable for differential driving. Route tracking will be simulated in LGS-LV program. RTK GNSS model will be used in the system. In this way, error due to GPS will be minimized. Uninterrupted communication will be established between users and the vehicle by GSM Shield module.
This is our current cost table. However, according to the progress of the project, these values may change or we may need material change or additional material. We are planning to receive the materials with the TÜBİTAK 2209D project scholarship and the financial support of the sponsor. Like every project, our project also has some risk factors. The biggest risk in the project is the financial risk. For example, the inability to get the financial support we planned, or if this support is insufficient for the project. When we have a financial support problem, we can change the component we use. Another risk factor is having problems in the operation of the system. In order to avoid such a situation, it is to simulate the system and test it in the computer environment before testing the project in the physical world. We planned our work plan to be as you see on the screen. The reason for the 2-week delay in our plan is due to the change of our advisor and the project topic. There may be changes on the program during the project. Our references are as you see on the screen. Thank you so much for your interest and attention.